Let's start with question number 7. Now, this question belongs to section of oscillation and waves and application of buoyancy, right? Let's see what the question says. The cylindrical plastic bottle of negligible mass of 310 ml. So, this is given to you and left floating in a pond with still water. If pressed downwards slightly and released, that means this is a case of SHM, it starts performing simple harmonic motion at angular frequency omega. If the radius of this base of the bottle is 2.5 centimeter, we want to find the value of omega. So, in order to solve this, let's see the diagram first. Solution. Now, as per the diagram, you can see this is the bottle. Weight of this will be downward and buoyant force will be acting upward, right? Buoyant force currently will be equal to mg as it is balanced. Let's suppose this is length small l, which is inside the liquid. Total length would be capital L. Now, if I press this further down and let's suppose I press this like this state where the length inside the liquid will be L plus Y. In that case, a new buoyant force will come, that is V inside into sigma into G. This V inside would be area of this base L plus Y into sigma into G. This would be B dash, right? Now, the initial existing buoyant force was simply equal to what is B? That would be volume inside the liquid. What was the volume inside the liquid here? That is the area into length into sigma into G, right? And this B is equals to mg here. At the new point of time where mg is still acting downward is this case and B dash is acting upwards, B dash will be greater than this mg. As you can see, this L plus Y and normally it was L sigma G here. B dash being extra or more or greater than mg, it will push the body upwards. That will create a restoring force and that restoring force value would be F equals to B dash minus mg. Putting the values of this as Y sigma G minus, instead of mg I am just writing A L sigma G. I have just calculated here this for you. I will find this is A sigma G into Y. This is the force. And you also know in case of SHM and small displacement, this restoring force is equals to Ky. So, for me the constant here would be A sigma G and you also know this is equals to m omega square, right? What is m? M is the mass of the liquid which is inside the bottle or the mass of the bottle right now. So, from here it's very easy to find omega. I will say omega equals to under root of A sigma G divided by m. What would be area? Pi into radius, this is 2.5, 10 to power minus 2 whole square. Sigma, that is density of water, would be 10 to power 3 kg per meter cube into G is 10 and this should be divided with mass is 310 ml, that would be 310 grams, and if I convert it into kg, I will get this, right? On solving this, you will get 8 radian per second approximately. Let's see which is the best suited option. So, among the available 4 options, our answer does not match to anyone. Hope this will be given to you as bonus, right? Let's move ahead and solve our next question, that is question number 8. Now, this question you see is from the section of heat and thermodynamics. Here, the half mole of an ideal monoatomic gas is heated at a constant pressure of 1 atmosphere from this temperature of 20 degrees centigrade to 90 degrees centigrade. We have to find the work done by gas. Now, it's a simple formula based question where you can say work done would be equal to pressure into volume, pressure being constant here. This can also be written as nR delta T, right? So, you have the value of n as half. So, work done would be half value of R into the temperature change. So, simply this would be 90 minus 20, that would be equal to 70 degrees centigrade. So, from here you will find the answer to be 291 joules approximately. Let's see which is the best suited option. Among the 4 options given, option number 1 is the right answer, right? Let's move ahead and solve our next question. So this question belongs to mechanics and along with the applications of electromagnetism. So a hoop and solid cylinder of same mass and radius are made of a permanent magnetic material with their magnetic moment parallel to their respective axes. Hoop means there's a circular loop. So there was a circular loop and a solid cylinder which were having same mass and same radii, and they were magnetic in nature and their magnetic moments were parallel to their axes. But the magnetic moment of the hoop is twice that of solid cylinder. So the hoop is a strong magnetic moment. It has nearly double the magnetic moment of the solid cylinder, right? They are placed in uniform magnetic field in such a manner that their magnetic moments make a small angle with the field. So the small angle suggests you that there will be an oscillatory motion. And in the case of simple harmonic motion of these cases, we have a particular formula for time period. If the oscillation periods of the hoop and cylinder are Th and Tc, find the relation between them. So before we move ahead, we have to know the relation of time period for such cases. That is simply T is equals to 2 pi under root I by mb. Now in the case of hoop, I can write it as Th 2 pi under root of I h by magnetic moment of hoop into the magnetic field which is existing in that place. And for circular cylinder, I will write 2 pi under root I c by mc to be, right. Now what is the moment of inertia of hoop? It would be simply mr square. What would be the moment of inertia of solid cylinder? That would be half mr square, right. So magnetic moment of hoop is twice of magnetic moment of C, right. So let's take the ratio of these two. Let's take this as equation 1 and this as equation 2. So I have Th by Tc is equals to under root of IH by IC into magnetic moment of cylinder by hoop. Now just put down the values. What I will get is, from here I will get 2, and from here this mc by mh would be 1 by 2. This is coming to be 1. That means the time period of oscillation of hoop and cylinder would be same. Let's see which is the best suited option. So among the given 4 options, option number 2 is the right answer for this question, right. Let's move ahead and solve our next question.